Hello and welcome back. It's been 3 weeks or so since I posted my second video on the threading jig, and since that time I have finished the threading jig and I've also made several items with threads on them using the jig. I was scheduled to run a demo on the jig at the Woodturners Guild, so I had to practice on a few items and get used to using the jig. Now, in the last video, I mentioned that I would make another video showing how the jig is used to make threads in your wood turning, and that's what this video is about. So today we're going to make a wooden box, a little bit like the one at the back here, maybe a bit smaller than that, but it's made from that type of wood. It's a New Zealand native Pahutakawa. We call it the New Zealand Christmas tree, and this particular wood has some nice black, I think they call it spalting in there, which gives it a nice look. So we'll make a little box similar to that, and we'll cut some threads on it, and I'll show you how it works. And then maybe at the end I'll just talk about some of the limitations and other upgrades that can be done with the jig. I start with these pieces of wood. These are two pieces cut out of a larger piece, and I've drawn out the centers already just using a plastic center finder and going around the various corners. Then I mark the points. This is for the steb centers to go into. And that's a steb center there in the headstock and one in the tailstock. Now I've just got to make sure that the tool rest is out of the way. I'm using a spindle roughing gouge here to make the piece of wood round. Now I need to cut tenons on both ends here, so I'm measuring out how far to cut down for the tenon. And this tenon is used to hold the piece of wood in a chuck. So that looks good. Now for the other side. I take the part out of the steb centers and remove the steb center in the headstock and wind the chuck on. Then the part is put into the chuck. Steb center in the tailstock is brought up. I mark out about a third. The small third is for the lid, and the other 2/3 is the box. I'm using a parting tool to cut through the piece of wood here. And I'd normally stop before it flies off the lathe, but it just went a bit too far this time. This is the lid, so I'm measuring 5mm in, and I'm just going to hollow out to somewhere close to that line there. And I'm using a scraper here just to get a nice right angle corner in there. I also clean up the face and just make sure that's square with a ruler, and put a little chamfer on the corner. At this point I sand the lid all the way up to 600 grit, but I don't apply any finish at this point. Here I apply some CA glue to the inside. This hardens the wood up a little bit. Now the chuck is removed with the part in it, and I install the MT2 collet and the cutter. And this is held in by a drawbar and a nut on the other side. The tool rest is removed and the threading jig is installed. The chuck is wound onto the threading jig, and I line up the chuck parallel with the lathe bed. I run the lathe at around 3000 RPM, and I advance the cross slide back about 0.2mm at a time, and I test for the cutter to touch the inside of that lid. And there it's starting to touch now, so I wind the lid back another 3 clicks, which is 0.6 mm, and I slowly wind the handle to cut the thread. Stop the lathe, back out the lid, and I apply some more glue and we set that off with some activator. I advance the depth another 0.4 of a millimeter and take the second cut. And these are the threads that have been cut. The next step is to measure the inside distance of the threads, and what we do is we add 1.1 millimeters to that, and that's going to be our outer diameter for the box part. First of all, we need to take the MT2 collet out, and we just loosen the nut off and give that a bit of a knock, and then that tool will come out the end and the collet can come out. The chuck goes back onto the spindle, and then we put our box in the chuck. The first thing I do is just clean the face off. Then I mark out the diameter we need using the vernier that I preset. I turn the outside down to the diameter that we need. It's a little bit tight, so a fraction more. And then after that I hollow out the inside of the box. Here I'm using the skew to go down the side nice and parallel, and I tidy up the tool marks on the inside with a round carbide scraper. Again, CA glue is applied to the outside to harden up the wood for threading, and we activate that off. Now at this point the inside can be sanded to 600 grit as well. Now we're set up for cutting the thread, and again I'm just advancing it in until it touches, and then from there I go in 0.6 of a millimeter and just slowly cut through the wood. The lid shouldn't fit on yet because the thread isn't deep enough, but I do always try it. And after that cut we put on some more CA glue and activate that off. And then we go in for another cut. Try the lid on again, and it's just fractionally tight, so I'm taking a bit of 200 grit sandpaper just to knock off the tops of those threads. Now this time I'm putting CA glue on, and I won't be advancing the cutter, so basically we're just clearing it out the CA in the threads and performing a cleanup cut. So what you see coming off here is probably mostly the glue. And that fits quite nicely. Again, just a little bit tight, so I'm just knocking the tops off the threads. Here I'm putting on some paste wax made of beeswax and mineral oil for some lubrication on those threads. And then that works quite nicely. Now we get into finishing, and I'm applying some U-Butte Triple E compound. Then I start the lathe up, and this polishes up the wood quite nicely. Next I put on my beeswax and mineral oil mixture, and again that's burnished in with heat from the lathe running. The base is removed and I screw on the lid, and I do the same process with Triple E and beeswax as a finish. Now the base is put back on the lathe and the lid is screwed on, and I start cleaning up the outside of the box. I'm using the skew here to mark where the lid and the base meet. Finally, I remove the tenon on the lid, and I also shape the lid as well. Here I'm using a shear scrape cut, and you can see the very fine shavings coming off. That gives you a very nice finish. The outside and the lid are sanded to 600 grit. Then Triple E and the beeswax mix is applied for finish. The final step is to remove the box from the chuck and turn it around and remove the tenon on the bottom of the box. I'm using a paper towel here to hopefully not mark the inside of the box. And I'm being very careful here, and I'm cutting most of the time towards the chuck so that the box doesn't get pulled off sideways. Tailstock is removed, and I've finished cleaning off that little nub. And then I just got to make sure that it's concave so that the outside of the box is touching the table when it's sitting there. Again, sanding the bottom to 600 grit. Lastly, we apply the finish. The box is taken off the chuck. And the lid screws on like that. Well, there is the finished box, and it turned out really nice. You can see all this darker grain. I'm not really sure what it is. It's something in the wood, and I think that's kind of common for this Pohutukawa. So it came out really good. I've got a little bit of a chisel mark there that I didn't see before. Threads came out pretty good as well. I'll probably show some close-ups of these. On the box itself, there's no tear out there at all, and that is probably because this is Pohutukawa. It's kind of one of New Zealand's, I guess, harder woods. And I did use the glue on there as well, so I think that sort of helps. And you can thread with softer woods by using the glue, so that means that you don't actually have to just stick to hard woods. You can use some of those other softer ones as well. In terms of the lid, again, there's no tear out there that I can see. That all looks pretty good. So I'm pretty happy with that. So the end product came out pretty good, and we'll go over to the jig and maybe just talk about a few things with that. Firstly, I'm very pleased with the performance and the results I get from the jig here. Using it is very simple, so anyone with not much experience can use the jig and get some good results. One thing I didn't talk too much about was the cutter. So this is a 60-degree double angle cutter. If I try and get a bit of an end on there, you can sort of see the 60-degree point in there. And this one here has carbide inserts brazed to it. So that's the cutter that I'm using. I couldn't find a cutter here in New Zealand. I presume they do sell them here, but I just couldn't really find anything that's suitable with the double angle on there to cut 60 degree. So I had to buy this from China in the end, and it wasn't that expensive, but you know, there's always a bit of a wait for these things to come through. Anyway, that's, I think, 12mm shank that fits into that collet that you saw me put into the spindle of the headstock. In terms of the jig, it works really well. The dovetails in here work great, so when this is loose, you would have seen there's a bit of a wobble. I don't know if you can see that on camera, but when the chuck's on here, it's quite obvious that it moves up and down, but as soon as you lock this lever down, those dovetails are pushing on each other, and that is absolutely locked solid. That's not going to be moving when you're doing the cutting. The detents in the end here are great. So these threads that I've been cutting here are 16 TPI, so basically that's around about 1 millimeter in depth, and so I know that one complete turn is a full millimeter being pushed in forward or backwards depending which way you turn it. And of course I've got those 5 detents, so I can just go in 0.2 of a millimeter increments. The hinge part works great as well, so that's really necessary so that you don't have to keep moving the jig out of the way to test, you know, your lid or box together, and then try and line it back up if you need to make another cut. So it just hinges up, and that is quite firm. That's quite well machined in there, nice and tight tolerance, so no movement there. That won't fall down, although you can put the pin back in there just to stop it from dropping down if it ever did, but that is nice and firm and there's no play there. And I know that once this is brought back down and I tighten that bolt back up in there, then that's in exactly the same position as before, and I can take another cut if I need to take another cut. The spindle assembly in here works well. I've got nylon plugs in here, so there's 3 of them evenly spaced around here that push onto the thread, and that makes it nice and firm, and also takes up any slop that, you know, would have been in there. With metal threads, you need to have some sort of clearance in there, so you're always going to have some sort of backlash, you know, whether it's a lot what you find on some bolts and nuts, or whether it's not a lot where you'd find on some higher spec machine threads. So this thread here is machined quite close tolerances, so there's not a lot of backlash in there to start with, and those nylon plugs make it even better. Now the limitation here with this particular thread, this is 16 TPI, so that's the thread that gets cut into the work that's on the end in the chuck. And I don't know if you just noticed earlier when I was screwing the lid back on the box, I have to wind it around quite a few turns to get the lid on. So this is a relatively fine thread, and I chose this thread because it's quite common when you're watching YouTube videos on threading. The hand chasing tools are 16 TPI and threading jigs are 16 TPI. But with this tool we can certainly adapt and make it better, and I've put that into the design as well. So let's grab some hex wrenches and show you how that works. So the spindle assembly can be removed by taking the handle off. Just one little screw there. And then there's this screw in the top. It gets loosened, and then that whole assembly can then come out. So if I wanted to make another spindle with, say, 8 TPI, like the threads we have on here, then I'd need to make another spindle assembly. So it's this black piece and the silver piece, and it would have 8 TPI on here and inside the silver piece. And then once you've made that, well, you could make 8 TPI or a metric thread or virtually any thread you want. You're sort of unlimited. But once you've got that built, that would slide back in here. We just lock down that screw, and we'll put our handle back on. And then you would be up and running with your new thread. So as simple as that. So that's pretty much the threading jig done, and an example of how we use it to make threads on a wooden box. Look, if you've got any questions, please put them down in the comment section. And if you'd like to be notified when I release new videos, then click on the notification bell and subscribe. I hope everyone has a great day, and once again, thanks for watching.